Hi friends, in this video we are going to discuss about the concept of mesh analysis. So here the meaning of mesh is loop. It means by using the concept of mesh analysis we can easily find the value of currents which are flowing in the loops. It means the current flowing in the loop 1 and current flowing in the loop 2, if you want to find, then if you want to find these currents, that is current flowing in the loops, it is mandatory to apply mesh analysis concept in any circuit. Okay, now we are going to solve this problem with the help of the mesh analysis concept. Okay, now actually in order to get the currents which are flowing in the loops, so we are having two loops, that's why the two currents are flowing. The most important thing is the direction of current will always decided by the sign of the voltage source. Okay, so here plus minus sign is there, so that is the reason why the current are flowing in the loops like this. Now in order to get the value of I1 and I2, just simply we can apply Kirchhoff voltage law in loop 1 and loop 2. Okay, so just apply Kirchhoff voltage law loop 1 and loop 2. Now we are applying this KVL in loop 1 and loop 2, you will get two equations. So depending upon the expressions we are getting by applying KVL, so by solving those two expressions you will get the value of I1 and I2 which are flowing in the individual loops. Okay, now first what I am going to do, I will draw the separate diagram for loop 1 and loop 2, because if you want to apply KVL in loop 1 and loop 2, so you must know how we are drawing the separate diagrams for loop 1 and loop 2 and what are the current direction. So this point is very important. Now coming to loop 1, while we are drawing the loop 1 diagram, we need to include all the components which are connected to loop 1. Okay, now see here, so this one is the R1 is equal to 10 ohms, and this one is applied voltage V is equal to 50 volts, and here coming to this point, R2 is connected between loop 2 and loop 1. That is the reason why when we are going to drawing the separate diagram for loop 1, we need to include R2 for loop 1, and when we are going to drawing the separate diagram for loop 2, again we need to include this R2, because this R2 is the mutual resistance connected between two loops. So that is the reason why we need to include this R2 for both loop 1 as well as loop 2. Okay, now this one is R2 which is connected. Now see here, the most important point is I am not considering the elements which are connected in the loop 2, but for simplicity or for getting the clarity how we are drawing like this, so for that purpose I have taken the value of resistance R3. Okay, now see here, just forget about the loop 2, just we need to concentrate only on loop 1. Now for loop 1 R1 is connected, and loop 2 for loop 1 R1 is connected and R2 is also connected. R2 is connected between two loops, just I am showing like this. Okay, now depending upon the applied voltage, now the direction of current which is flowing in the loop 1 is like this, but see here the current flowing in the loop 2 direction also here clockwise, while the current flowing in the loop 2 is clockwise means, but when we are going to observing the direction of current through this R2, this is in the upward direction. Okay, so current I2 through this R2 is upward direction, and current I1 through this R1 is downward direction like this. Okay, it means whenever we are going to apply KVL in loop 1, we need to take the difference of these two currents while we are writing the expression for loop 1 as well as loop 2. Okay, now here when we are writing the expression from for loop 1, here the difference of current always I1 minus I2, and when we are writing the equation for loop 2, the difference is always I2 minus I1. Okay, now here just apply Kirchhoff voltage law in loop 1. Now see here, apply KVL in loop 1. Now what is the definition of Kirchhoff's voltage law? Total applied voltage is equal to sum of voltage drop across individual elements. It means what? It means how many elements are connected to loop 1. So across those individual elements, we need to get the voltage drop. Here, the voltage of across R2 resistance is VR2. The voltage of across R1 resistance is VR1, and this is the total applied voltage. Now by applying KVL in this loop, you will get total applied voltage V is equal to the sum of the voltage of across individual elements like this. Okay. Now we know that V is equal to I into R. This expression we always use it to find the voltage of across individual elements. Yes or no? So that is the reason why what we are doing. So if the current flowing in the loop 1 is I1, for example, we are taking. Now see here. So applied voltage V is equal to VR1 means voltage of across R1. It means VR1 means here I1 into R1. Okay. Instead of VR1, we can write I1 into R1 plus VR2 is the voltage of across R2. But this R2 is connected between loop 1 and loop 2. It means we need to take the difference of the currents which are flowing in the loop 1 and 2. That is the reason why we are writing I1 minus I2 into R2. Okay. Now this step is very, very important. Okay. So V is equal to I1 into the value of R1 is how much? 10 plus value of I1 we don't know, because our target is to find this. Our target is to find the value of I1 and I2 only. Now coming to R2. R2 is how much? 30. Now V is equal to 10 I1. By simplifying you will get 30 I1 minus 30 I2. Now V is equal to 30 I1 plus 10. It will give 40 I1 minus 30 I2. Now we know that applied voltage in the circuit is 50. So here 50 is equal to 40 I1 minus 30 I2. Now this is the expression 1 we are getting from the loop number 1. Okay. Now same like this we need to apply KVL in the loop 2 after drawing the separated diagram for loop 2. Now see here. So now what we are doing? Now we are simply drawing the separate diagram for loop 2. Now loop 2. What is the separate diagram for loop 2? What are the elements which are connected to loop 2? We need to consider only those elements. Okay. Now this one is R3 is equal to 50 ohms, and here the value of this one R2 is equal to 30 ohms, and the direction of current is like this. This is I2, and here this one is R1, but we are not including this value in the loop 2. Okay. Now see here again same apply KVL in loop 2. Apply KVL in loop 2. Then we know that the definition of KVL is total applied voltage is equal to the voltage of across individual elements. But here we do not have any applied voltage source for loop 2. Okay. For loop 1 only the voltage source is connected like this. But loop 2 we do not have any voltage source. So that is the reason why. So 0 is equal to the voltage of across R3 VR3 plus the voltage of across R2, that is VR2. Now see here, whenever we are going to observing the current flowing through this R2, just you can observe here, the current I2 is flowing upward through this R2, and here the current flowing through R2 I1 is downward. It means whenever we are writing the expression from loop 2, so always we need to consider I2 minus I1 for R2. Okay. And for R3 directly we can multiply. Okay. So that is the reason why VR3 it will gives, so I2 into R3 plus VR2 means I2 minus I1 into the value of R2. Okay. Now 0 is equal to I2 into what is the value of R3? 50 plus I2 minus I1 into what is the value of R2? R2 is 30. Now here 0 is equal to, so 50 I2 plus 30 I2 minus 30 I1. Now 0 is equal to 50 I2, 30 I2, it will give 80 I2 minus 30 I1. Now from this expression what I am doing, I am writing the expression of I1 in terms of I2. It will give what? So 80 I2 is equal to 30 I1. From this expression I am writing I1 is equal to, so 8 divided by 3, because 0 0 gets cancelled, you will get 8 divided by 3 into I2. Okay, now assume this is equation number 2. Now what we are doing, substitute equation number 2 in equation number 1. By substituting this value in equation number 1, you will get the value of one parameter or one value. Now see here, what is the expression of I1 actually? What is the expression of I1? 50 is equal to 40 I1 minus 30 I2. So we are writing this expression. This is from equation number 1. That is 50 is equal to 40 I1 minus 30 I2. Now in place of I1, I am substituting the value of equation number 2. That is 50 is equal to, so 40 into I1 means 8 divided by 3 into I2 minus 30 into I2. Now simplifying here, so 50 is equal to what is the value of this one? So 40 into 8 divided by 3 into I2 minus 30 into I2. Now by simplifying, you will get 40 into 8 divided by 3. It will give the value as 106.666. This is the value of 40 into 8 divided by 3 into I2 minus 30 into I2. Now just simplify. It means, so we are having the value of 106.666. We are subtracting 30 from this one. You will get the value as, so 76.666 I2. Now from this expression, we can get the value of I2. I2 is equal to 50 divided by 76.666. Now by simplifying this one, you will get, so 76.666 divided by the value of, sorry, that is what, 50 divided by 76.666. It will gives the value of current I2 as 0.6521 ampere. Now this is the value of I2. Okay, now I assume this is equation number 3. Okay, now substitute this value of I2 in equation number 2. Okay, now see here, what is the equation number 2 actually? The equation number 2 is what? Now the equation number 2 is what? Just see here, whatever the equation we got in the previous step, that is I1 is equal to 8 divided by 3 into I2. That is, from equation number 2 we can say that I1 is equal to 8 divided by 3 into I2. But here we got the value of I2 is equal to 0.6521 amperes. So here the value of I2 is equal to 0.6521. So this is 0.6521 ampere. Now substitute this value instead of this I2. So that is I1 is equal to 8 divided by 3 into 0.6521 ampere of current. Now by simplifying this one, so 8 into 0.6521 divided by 3, it will gives the value as 8 into 0.6521 divided by 3. It will give the value of current as 1.7389 amperes. Okay, so this is the value of I1, and I2 is equal to 0.6521 ampere. Now this is the value of I2. Okay, so it means the given circuit is like this, and we calculated the value of I1 and I2 which are flowing in the individual loops by applying the concept of mesh analysis. Okay, but while you are writing the expression for loop 1 and loop 2 at the mutual resistance, that is the resistance between loop 1 and 2, so you need to take the sum of currents. That step is very, very important. Okay, so like this we need to go for the calculation of I1 and I2 by applying mesh analysis concept. Okay, so this is the procedure we need to follow whenever we are going for the calculation of loop currents by using mesh analysis concept. Okay, thank you so much for watching, and please do subscribe my channel for more updates. Thank you.